Hello everyone, this is Jia Chen. I'm recording for the EC 6303 homework 7. This is problem 8. We need to discuss the Poisson distribution. And first thing, we know that from chapter 4, and we know what's the Poisson distribution is just basically the px equals to k is e to the power minus lambda k and k times dot dot dot. Then we know that we can get the derivative into different power. Then we can get basically what the expectation of x and sigma. So this is just the derivative of the original equation here, and we can get the result based on the expectation derivative of different order. Then we can get the result. And we know that we have already done such a homework in the previous. We can check it and check whether we did it right or not. Like I will take example. So the k here and lambda e to the power lambda into sum it, then we can get the derivative of both sides. We can get it's a k e minus lambda. Actually, we can know that this is just a derivative from previous one. Then we know that this is basically what we need for expectation of x. And the first question is quite easy. So sigma is just, we can write on the equation, it's just x squared minus ex squared. So the inner square or outer square. Then we can get the result of sigma squared. And it's quite easy. We can check it from the Poisson distribution in the lecture note or the book. And for the second question, we need to discuss the T1, T2, and they are not overlapping. And the first thing we need to do is calculate R T1, T2. And this is the same as we have already mentioned in the previous problem. And if T2 greater than T1, xt1 is equal to xt1 minus xt0, xt2 minus xt1. These two things are independent. Then we know that Poisson is independent increment process from the textbook. Then we can just basically analyze it and then get the result for even for T1 it's greater than T2, and analyze the R T1, T2, then we can get the results for the question. And that's all for this homework, and we can go to see the results. As we just mentioned, T2 greater than 1, T1, R T1, T2. And the first question is quite easy. I don't need to explain more. I just need to get the derivative and move it to get the expectation from the previous. Analyze Then this is just, we need to use this equation here, and we can directly use the same way to get the ex square. Then we get the sigma square. And I think that's all for this homework. It's quite easy to analyze R, T1, T2 to get the result. That's all. Thank you.